All right, part 2 to the state of the atmosphere. So we're looking at some basic definitions here. The first is temperature, which is a measurement of how rapidly or slowly molecules move around. And then heat, which is a transfer of energy that occurs because of a difference in temperature between substances. So as you can probably guess, measuring temperature, just going to do whatever it wants to do, can be measured 3 different ways. You got Fahrenheit, which is what we're used to, Celsius, which is what scientists use, and Kelvin, which is also used by scientists. Kelvin's usually used when you're dealing with extreme temperatures. Celsius with your average every day, and somewhat high, somewhat low. And then once again, Fahrenheit, what you're used to. So you guys won't be really dealing with Kelvin. Celsius mainly in class. The easiest way to remember, Celsius 0 degrees is the freezing point of water, and 100 degrees Celsius is the boiling point, and then everything else falls in between. So that kind of gives you a feel for it right there. All right, so wind. How do we have wind, which is part of the atmosphere? It is caused by the unequal heating and cooling of the Earth's surfaces. And when you do this, you get in turn you get areas of high pressure and low pressure, which are going to be a big deal when we're talking about weather. So remember, all parts of the Earth doesn't always heat the same, depending on where you're at the equator or the poles or somewhere in between. You're going to get differing amounts of the energy from the sun, heat from the sun. And also depending on if you're water versus sand versus soil versus stone, all those things heat up differently and hold heat differently. Wind itself is moving from areas of high pressure to areas of low pressure. And wind speed usually increases with height because there is less friction up there. So we got some information on the Coriolis effect. Think about that as almost like a swirling of the Earth's atmosphere. So when you think about changes in atmosphere, because the atmosphere is going to go from something that's really warm, the air is going to rise, move towards cooler areas, sink, and then come back to the warmer areas. Rise again, sink, come back to warmer areas. But it doesn't go nice and neat straight up and down because the atmosphere is what it is, it's gas. And because the Earth moves, it actually causes the atmosphere to actually kind of curve. And the Coriolis effect, along with this unequal heating of the Earth's atmosphere, actually causes these big global wind systems. So we're not talking about, like, say, wind that is occurring in the Raleigh area. We're talking about hundreds of miles of wind systems that go on a regular basis. So in each area above the equator and below the equator, there are 3 convection cells, areas of warm air rising, cool air sinking, warm air rising, cool air sinking, warm air rising, cool air sinking. And the first kind of convection cell is called the trade winds. It starts at the equator and goes right above the equator and right below the equator. And it's called trade winds for a reason. It's because these are the winds that sailing vessels use to go from, well, to go everywhere, from the new world or from the old world to the new world. So here you got some of the big ones here. You got the trade winds, the prevailing westerlies, and the polar easterlies. And you got the southeast trade winds, prevailing westerlies, and the polar easterlies. Once again, right here at the equator, going up this way, and then going down this way. And then right in here, you have an area where the wind doesn't do jack, which is an area that, you don't want to be if you're an old school sailing vessel, because it generally means starvation and, bad things happening. The same thing right here and right here. These are areas where the winds are kind of weak and bad things happen. So just kind of a little background. Horse latitudes were called the horse latitudes for a reason. A lot of times these ships, due to storms or just due to maybe some bad sailing practices, would end up in the horse latitudes, and there wouldn't be like any wind. And remember, these guys are going from like Europe to over to the New World, and they'd be packing everything, you know, their cows, their pigs, their chickens, and their horses. So if you're going to be stuck in an area for a while and there's no wind, remember there's no refrigeration units, and you can't turn on a faucet to get water. You've got to rely on rain, and you've got to rely on the water you have stored on the ship. So there's a problem here, because if you're stuck for a long time, you're going to be using up your food and your water sources. And horses drink a lot of water. So when things start looking a little bad, the first thing that goes overboard are going to be your horses. Hence the term horse latitudes. And I'm sure they slaughtered a horse here and there for dinner, but they couldn't keep the meat because remember, no refrigeration, so that stuff's going to go bad really fast. And let me tell you, you do not want to have stomach issues on a ship when you don't have a whole lot of water. Because remember, if you're having diarrhea, you are losing a lot of fluid, and you're going to need fluid to make it up. And that's one of the things that killed a lot of people, were stomach issues like that. So, you know, they wouldn't be keeping a lot of these animals for any length of time once they're slaughtered. They'd just be sent overboard. It'd just be the easiest way to deal with it. Your other wind systems, the prevailing westerlies, your polar easterlies, and one other coming up here called the jet streams. Now, this is one we didn't even know about until, until we were flying, and flying high. These are narrow bands of high altitude westerly winds. They literally look like ribbons of air that flow around the world, and those ribbons go up and down. Almost like having a belt that goes from your head, and can move to your shoulders, it can move to your stomach, then move to your feet, and then move back up again. They're really, really fast. There are two of them. There's a polar one, which brings cold air to an area, and the subtropical one, which brings warm air into an area. And they can do a lot to weather when they move in, and there is no rhyme or reason at really how this stuff moves. So if you get a polar jet stream in an area, it can just change local weather amazingly. Oh, with jet streams, some of the things that pilots actually would use these guys, they would get their planes on the where their tail of their plane is I guess how we call it, the wind would actually be pushing their plane, so they would sometimes get places a bit faster because they would have an extra added push. And they would also save on fuel because they would have to use less fuel. So here's a big thing. Weather systems generally follow the path of the jet stream. You can change air temperatures big time. All right, so we're stopping here, guys.